This is the Sendy car. It is the brainchild of engineer and four-time Pikes Peak champion Robin Shute and his team, who call themselves the Sendy Club. I've done several videos on their exploits at the hill climb race, but those were all done in the previous car, a highly modified Wolf prototype car. That car does not exist anymore because Robin turned it into a low-flying airplane at Laguna Seca. He's fine. The car is not. But that's okay, because there is a replacement car that has more horsepower, more cylinders, more downforce, and more carbon fiber. And the team is planning on running it at this year's Pikes Peak hill climb in June. June is real soon, and the car does not yet have a body. And while it looks really cool without a body, it is not aerodynamical. The people who were supposed to make the body could not finish it in time, and quotes from other companies were coming in at nearly $200,000. But I convinced Robin that we could print it for 1% of that cost. You'll have to watch the video to decide whether or not that was a good or bad idea, but I will say right up front, it was definitely an idea. The Sendy car follows the design of the old car with a somewhat uncommon layout of open wheels in the front and covered wheels in the rear. The under tray is done, as are the ducts and the nose. We will be making this part. But in an effort to make this a more reasonable undertaking, Robin decided to cut the size down to just this. All this part will be left uncovered, partly because it doesn't matter that much aerodynamically, and partly because it all looks pretty cool. It's sort of like a race car that's not wearing any pants. Unless you think race cars wear pants like this, instead of like this. In that case, it is a race car wearing assless chaps. The idea here is to split this up into three parts, the two side pods and the engine cover, and then further split those up into chunks that will fit into my bamboo printers. That's about a 12-inch cube, or in the metric system, half of a cubic baguette. This means the body will need to be made in 34 separate pieces. We're going to print this out of PAHTCF. This is a high-temperature nylon. That's one of my favorite filaments for things that will see some abuse. We use high-temp nylon for a couple of reasons, the first being the high-temp part. The body gets really close to the heat exchangers, which are, as you may have guessed by the name, pretty hot. There's also the charge pipe from the turbo and the engine itself near the back parts. Nylon is also super strong, so this will help with rock chips and dents. Probably you could use cheaper filament and more layers of carbon fiber, but there's only one Pikes Peak race every year, and you only get one run, so we decided to make it real tough. We will assemble this in the same way I assembled the bump out on my van. The pieces will be located to each other with small dowels, and they will be glued together using some structural adhesive. An engineer who works for 3M in the adhesives department messaged me after that video to tell me that I used the wrong adhesive. I used DP420, but he suggested 8910 for nylon. So for this project, we used some stuff Robin had lying around. It's probably fine. We're not going to just glue this all together and call it good. I made that mistake on the van. No, we are going to glue this all together and then wrap the outside and inside with carbon fiber. Some people might say that this is less of a 3D printed body and more of a carbon fiber body with a 3D printed core. I think it's a reinforced 3D print because the print is doing a lot of the hard composites work. You don't need a mold, you don't need a plug, you don't need to release anything from anything else. There's no specialized tooling, there's no vacuum bagging. This is about as easy as composites gets. The panel prints were averaging about 12 hours each. I have two of the larger bamboo printers, so we had both of them going non-stop for 2 solid weeks. This took 10 rolls of nylon, over 2 miles of filament. Bamboo supported the build by sending us over the filament we needed. They also supported the build indirectly by making some pretty awesome machines. So if you want to make your own 3D printed race car body, check out the H2 printers by clicking the link below. We actually had to get some extra filament because we may have messed up on some of the parts. A few of the first prints had problems. The filament just wouldn't stick to the build plate. This is sometimes a problem with high temperature filaments on tall, skinny parts. The corners were peeling up as the prints progressed, so you get a bottom edge that's not flat. I had the same thing happen on the van bump out, but it wasn't enough to matter. We did some research and came back with 2 ideas. The first one was easy. I was using the wrong build plate. High temperature stuff should be on the engineering plate, prepped with glue. Probably should have known that. In an effort to further mitigate the problem, we added some features on the bottom to keep the bottom edge attached to the plate. These blocks are 1/10 of a millimeter away from the part body, and they have little teeth that protrude into the part. The idea here is that these are larger than the thin brim that normally sticks to the plate, so they won't peel up as easily. These worked great, and we popped them off with some pliers with ease. So we modified them to get rid of the teeth. Now they're just blocks offset by 1/10 of a millimeter. And everything was great for a little while, and then not so great. Most of the blocks came off cleanly, but some didn't. Some stuck on there. We didn't realize this until halfway through printing, so a bunch of our parts had blocks stuck to them. We didn't know if the engineering plate alone would keep the parts stuck down, so we kept the blocks on to be conservative and not waste filament, and it was looking like that had caused us to waste filament. We tried to fix this by putting the old printed parts back in the printer to heat up, hoping that the blocks would warm up and come off more easily. This did help on a few of the prints, but not all of them. So we just got rid of the blocks and finished printing everything with some reprinted parts. And everything was fine. So if you want to print tall nylon parts without the edges warping up from the build plate, you just have to use the engineering plate. In the end, we had 8 extra parts. Most of them had the blocks stuck on. 2 of them were printed on the wrong build plate, and 1 of them we just accidentally printed twice. I did some light durability testing on one of the extra parts, and it turns out that nylon is pretty tough, but not invincible. So we will have to reinforce it with some carbon fiber. With all the parts printed, we began assembling the parts together. We tried to keep everything labeled so that we wouldn't print more than one of each part, but we didn't label where each part went on the car. So the whole thing was like a jigsaw puzzle, and we were not very good at it. But we did eventually get it all together. The dowel pins were there to line everything up, but we noticed something interesting. They didn't all line up to each other, so we had to remove some of them. PAHT has pretty good dimensional stability, but you do still get some shrinking with it, and the shrinking changes based on how you orient the print. We didn't orient all of these prints in the same direction, so some of the pins just had to be removed, which turned out to be fine, actually. We got all the parts together and then realized we were missing one, so we printed that. While that one was printing, we let the durability engineers have a crack at it to see if we could get away with just using painter's tape to hold it together, and they concluded that no, we needed actual adhesive. We moved the test fitting to the car and noticed a few issues. There was some reinforcement in the floor that needed to be cleared, and there was support for the radiator that was not correctly loaded in CAD when designing around it. So we had to make some modifications for that to work. The duct on the right side was not lining up at all, which we traced back to the duct itself being mounted too high, or at least that was the easy way to fix it. So we cut some slots in and moved it down to line up better. It was decided that the assembly should happen on the car so that everything kind of lines up where it should with the car. And it was decided that we should make some precautions to not have adhesive drip all over the radiator. We set out all the pieces and then one by one cleaned the edges, applied adhesive, and assembled our jigsaw puzzle onto the car, taping up all the pieces together as we went and making sure everything lined up. One of the panels wouldn't stay lined up, so we fed beer to one of our Kiwi friends who held it in place for 10 minutes while the glue set. And that was it. After that, we were all done with part 1. Earlier I mentioned this was a pretty straightforward composites project, no mold or resin infusion or anything like that. What I didn't say is that the easiest possible composites project is still kind of a pain in the ass. The first step here is to do some testing. Nylon is a low surface energy plastic, meaning things don't like to stick to it very well, including adhesives. That's why we were supposed to use that special adhesive that we didn't use. Part of the reason we didn't use that is because we're not really relying on the bond strength between the different panels. What we are relying on is the bond of the carbon fiber to the outside of the panels. We do need some bond between the panels, but really we need a good bond on the carbon. So we took a few of the extra parts we had printed and tried some things. We tried 4 things. The first was doing no prep at all, which is what I was rooting for. We also tried sanding with 80 grit sandpaper. We tried with some spray adhesive, and we tried with both spray adhesive and sandpaper. The spray adhesive is not to help bond the carbon and nylon, it's just to make it easier to lay on the carbon fiber. We let those cure overnight and then tested them out. One of the parts we added carbon to was the one I broke earlier, and I tried to break it again, and it was much stronger this time. The test pieces made it pretty clear which direction to go. The spray adhesive acted as a barrier between the epoxy and the nylon, so it peeled off pretty easily. Otherwise, there was pretty good adhesion, but the sanding definitely helped. So we were going to have to sand these parts, which actually we would need to do anyway because we had to go back and add in some filler in some spots where there were gaps. We did this with some epoxy repair filler, mixing it together and smearing it into the cracks. This helped, but we also had to add some more adhesive into the cracks on the backside to make sure it was all filled out. If I were doing this again, which I probably will, here's what I would do different. The first is that I wouldn't use dowels to align the parts together. I'd add a tongue and groove to the edges. This would allow for some misalignment side to side, but would accurately align the top surfaces. It also gives the bonus of adding more area for the adhesive to bond to. And then, instead of relying on crappy tape to hold it together, I'd use hot staples. You use a gun to heat these up and press them into the plastic, then let them cool and then clip off the ends. We talked about doing this, but ended up not because we were running low on time and decided the quick and dirty approach was the way to go, which we should know by now always takes more time. Anyway, we did get it all assembled eventually. We got it smoothed out with lots of sanding. Now, if you know me, you know I hate sanding. Like, I super hate it and I never want to do it. But honestly, on this project, I did not mind the sanding at all. Probably because I didn't have to do any of it. And there was a lot of sanding. So much sanding. Sanding down the filler material, sanding to get the seams smooth. But finally, we were done with sanding. Well, part 1 of sanding. So I said this was easy as far as composites go, and it is. Laying up the carbon is really easy. We started with the engine cover because that was the easy part, and we wanted to fool ourselves into thinking that everything would be just as easy. We laid down the carbon over the part and trimmed it to just a little bit oversized on all edges. Then we weighed the carbon and mixed up epoxy that weighed about 120% as much as the carbon. Then we painted on a thick coat of epoxy directly onto the nylon and carefully laid the carbon on top of that, rolling it down into the epoxy. After it's all on there, you paint the remaining epoxy on the top of the carbon to make sure it's all saturated. After that, it was time to gently roll on the peel ply. Peel ply is a plastic fabric that lets some of the excess resin transfer through it, so you get a consistent surface finish on the outside and a better ratio of resin to fiber. We also laid up a layer of carbon on the inside, giving significantly less effort since nobody will ever see this side, except for you and me and 600,000 other people on YouTube. The side pods were further prepped for carbon with some knife work to help the epoxy stick, and honestly, after all the gluing and sanding, they were looking really good. The carbon fiber on the side pods was done the same way, except we had to use multiple pieces of carbon and cut it to fit on there. We got all the pieces test fit and ready to go, and then just a lot of painting on epoxy and rolling on carbon fiber. The other side was done the same way. The next day, we removed all the peel ply and trimmed up the edges of the carbon fiber that extended past the 3D prints. And then, you'll never guess what the next step is. That's right, sanding. Hours of sanding, probably. I actually just got like 30 seconds of video and then went inside and watched hockey while they all finished it. We did add some fairing compound. This is a 2-part filler that's great for smoothing out surfaces and filling in pinholes. It also requires lots of sanding, which I also did not do. It was about this time that we remembered the car was set to debut the next day at a car gathering in the city. So we test fit the side pods on the car, and they looked great. Really good considering how little sanding I had to do. Now, if you're thinking that the fairing compound ruined the carbon fiber look, you are right. But the plan was never to have carbon fiber exposed. We are going to wrap it. And wrap it we did. Stretching and cutting, and I also did none of this because I am not good at wrapping. The other guys are also not great at wrapping considering we ran out of wrap at 11 p.m. the night before the car was supposed to be displayed. So we got desperate, trash diving for scraps and using some vinyl wrap made for sticker cutters. We got it done with mere hours to spare. Was it great? No. Was it good enough? Certified. Not bad for a few days of work and a couple $1,000. We will have to rewrap the body in the future to make it look nice, and we still have not done the inside layer of carbon fiber on the side pods. And also, they are not physically attached to the car in any way. But none of that matters because we loaded up and made it to the event, where everyone was thoroughly impressed with our 3D printed race car body, and also probably a little unimpressed with our vinyl wrapping skills. We did finish up all that other stuff, and the car was loaded up and sent to the Pikes Peak Hill Climb race, which is tomorrow. So check out the race, and good luck to Robin and the Sendy Club. I expect you to be super fast.